Alright guys, good day to you all from wherever you are watching this video. This will be our first official maths video for your post-UTME exam. So this video is for those preparing for their post-UTME. Probably you've passed your JAMB, you crossed 200, or you beat the cutoff mark for your desired institution. This video will be very helpful for you. So in today's video, we are going to talk about indices, but I'm quite sure that you have subscribed. If you have not subscribed, please do not forget to click the subscribe button and turn on your notification. Right, let's kick off to indices. Now, when you hear of indices, we are talking about powers. Once you come across the word indices, we're talking about power. It's actually just a plural. The singular of it is index. So there's something so unique about indices. It did not start with a proof, it actually started with a suggestion, which led to so many things, which made maths simple. Now let's say you have 2 times 2 times 2 times 2. This is just 16. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Now, if you have something like this and you want to tell a friend this, what indices is trying to say, why not, how do you reduce the stress of writing 2 times 2 times 2 times 2 into 4 places? Or let's say you want to tell a friend 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. Let's say you want to tell a friend this. How do you reduce the stress of writing this? This is where indices comes into place. So mathematicians of old, they said instead of writing this 2 in so many places, let us indicate the number of 2's by writing it at the top of the 2. So by writing it at the top of the 2, for this we have 4 2's. Now if you write it as this, 2 raised to the power 4, what it means is 2 times 2 times 2 times 2. There is no proof that 2 raised to the power 4 means this. It was a suggestion that anytime you see a number at the top of this is called the base and this is called the index. That this is what it means, multiply 2 into 4 places. Now, someone also suggested that what if you write the 4 at the back instead of writing it at the front? What this means is actually 2 raised to the power 2 raised to the power 2 raised to the power 2. So for this one that 2 appears into 7 places, it is written as 2 raised to the power 7. So this was the first suggestion that led to the laws of indices. So there are basically 7 laws of indices. These laws were started from this particular observation and this particular suggestion. So now let's dive into this laws of indices and how it came about. Let's say you have 2 times 2 times 2 and you want to multiply it with another 2 times 2. Now 2 is appearing how many times? 2 is appearing 3 times, so we simply write it as 2 raised to the power 3 times 2 is appearing twice, so we simply write it as 2 raised to the power 5 and 2 raised to the power 2. But if I'm to do everything together, 2 times 2 times 2 times 2 times 2, 2 is appearing 5 times. So it means that this 2 times this is actually 2 raised to the power 5. So what we are trying to say in essence is that this is equal to this. So what do you observe about these powers? What you observe is that when you add up these 2 powers, you will get this. So this led to the first law of indices, which says that when you have x as a base raised to the power a certain power times the same base x raised to the power another power, that the result is the base and the sum of the powers. So this is the first law of indices. This is the first law of indices. One thing about this law, you must note that they must have the same base. If this place was y, your answer wouldn't have been this. So they must have the same base. Suppose that this place was 3, it wouldn't have been 2 raised to the power 5. So the first thing you must note is they must have the same base. Let's say you have 2 raised to the power 5 times 2 raised to the power 6. Because they are multiplying, do not forget the first law of indices. you add the powers. So you have 2 raised to the power 5 plus 6, which is 2 raised to the power 11. It could be 3 times 2 times 3 raised to the power 7, or let me use a minus sign here. This is 3 raised to the power 1, so you have 3 raised to the power 1. Because you are multiplying, you add powers plus minus 7. So this becomes 3 raised to the power 1 minus 7, which is 3 raised to the power minus 6. So this is what first law does. Now let's move over to the second law of indices. Now there is no rule that says these laws must be arranged in a certain order. Whichever way, you are still saying the same thing. So do not start cramming that the first law of indices must be this. You can choose anyone to be your first law. Now let's say you have this. Let's say you have this. I'm going to be using lots and lots of tools to explain this. Let's say you have 2 times 2 times 2 times 2 times 2. 2 into 5 places. Then divided by 2 times 2 times 2. This is 2 into 3 places. Now, this is actually just 2 into 5 places is 2 raised to the power 5. And 2 into 3 places is 2 raised to the power 3. At the beginning, you will stop here because then the laws of indices have not come into place. But what will happen if you expand it here? One of these 2 can cancel out. One of these 2 can cancel out. One of these 2 can cancel out. So you are left with 2 times 2, which is 2 raised to the power 2. So it means that everything here is the same as this. Now, how do we manufacture a way that brings out a formula? Now, what do you observe about the relationship between these 2, 5, and 3? You observe that 5 minus 3 is 2. So this led us to the second law of indices, which says that when you have a base raised to the power m divided by x raised to the power n, because there's a division sign, what you do this time, you subtract the powers. So we have x raised to the power m minus n. So suppose you have 3 raised to the power 5 divided by 3 raised to the power 2. Your final answer will just be 3 raised to the power 5 minus 2, which is 3 raised to the power 3, or 27, as the case may be. So that will be all for law 2. Let's move over to another law. Let's move over to another law. Now, if you have 3 raised to the power 5 over 3 raised to the power 2, we just said we are to use the second law, which is 3 raised to the power 5 minus 2. 3 raised to the power 5 minus 2, because there's a division sign here. Now, we want to manufacture something here. We want to manufacture something. Do you know that this 3 raised to the power 5 over 3 raised to the power 2 is the same as saying 3 raised to the power 5 divided by 3 raised to the power 2? Yeah, they are the same thing. Now, I want to make this law looks like the first one. I want to make it look like the first one. So what I will do, instead of writing just minus, I'll write plus minus 2, since they are the same thing. Now, what's the first law of indices? If you have this, it can be simplified to this. So the base becomes 3 raised to the power 5 times 3 raised to the power minus 2. So we have 3 raised to the power 5 already, and we have 3 raised to the power 5 already. What it means is that this this other part, 3 raised to the power minus 2, is equivalent to this. So this brought about the third law, which says that when you have x raised to the power a negative power, you can rechange it to give a positive power. So this brought about the third law of indices. So let's say you have 3 raised to the power minus 4. This can be written as 1 over 3 raised to the power 4. The negative sign has gone out of it. This is the third law of indices. What if you have let's say you have 1 over 3 raised to the power minus 3. Now, to remove this minus sign, you will have to take it up, so you have 3 raised to the power 3. So whether the minus is here, if you are bringing it down, the minus goes out. But if the minus is at the denominator, when you are taking it up, the minus goes out. So that will be the third law of indices. This third law can be extended to another law, which says that supposing it was not 3 raised to the power minus 4, Supposing it was 2 over 3 raised to the power minus 4. What you do to remove this minus sign is to interchange the numerator and the denominator. So this is the same thing as 3 over 2 raised to the power 4. Here the minus sign has gone out. So this law is actually an extension of this. So like I said, all these laws will lead to several other laws. Now let's move to the fourth law of indices. Let's say you have 2 times 2 times 2 all over 2 times 2 times 2. Now this is actually just 2 raised to the power 3 all over 2 raised to the power 3. So from our second law of indices, we said since there's the division sign here, we have to subtract the power. So this is 2 raised to the power 3 minus 3. So that's 2 raised to the power 0. Now what is 2 raised to the power 0? We really do not know. Because as at when this law started, we didn't know what 2 raised to the power 0 is. But we want to show what 2 raised to the power 0 actually is. So if I cancel out all these 2, what will be left here is actually 1. So it means that 2 raised to the power 0 is 1. If I choose to use 3 raised to the power 0 will be 1. So this led to the fourth law of indices, which says that x raised to the power 0 is always 1. Meaning that any number raised to the power 0, this is not degree 0, is 1. Except x not being 0. You must note that x must not be 0. Because 0 raised to the power 0 is undefined. But that's a story for another day. So every other number raised to the power 0 should give you 1. 2 raised to the power 0 is 1. 3 raised to the power 0 is 1. 7 raised to the power 0 is 1. 8 raised to the power 0 is 1. 100 raised to the power 0 is 1. 0.1 raised to the power 0 is 1. So any number at all, so long that number is not 0, if you raise it to the power of 0, you will get 1. So that's for the fourth law of indices. Now let's move to the fifth law. Because of time, we won't be doing much of proof. We'll be going straight to the point. The fifth law of indices is saying that when you have x raised to the power 1 over a certain number, it could be an integer, it could be a fraction. What this means is m-ths of that power. Or let me not use this law first. Let me use another law. Let's say the fifth law is x raised to the power m. Now when you have x raised to the power m and you now have another power, this can be simplified to the product of the powers, x raised to the power m times n. So let's say you have 2 raised to the power 3, then you now have it raised to the power 2. What you do to simplify is just to multiply these powers together. So this is 2 raised to the power 6. If you want to be very, very sure, what is 2 raised to the power 3? This is 2 times 2 times 2, then raised to the power 2. Now what is square? It means multiply the same thing twice. So I'll multiply this by itself. So I'll have 2 times 2 times 2, then times 2 times 2 times 2. How many 2's are here? There are actually 6. So this brought about the fifth law of indices. Now let's move over to the sixth law. The sixth law of indices. Let's say you have x raised to the power 1 over m. It's actually another suggestion that anytime we say, let's say you have 4, and we are looking for two numbers that you can multiply to give you 4. Now we are not looking for 4 times 4. We are looking for two numbers that you can multiply together. Two the same numbers that you can multiply together that will give you 4. That number is actually 2. 2 times 2 is actually 4. So what they say, how do we tell someone that we are looking for two numbers that are the same, but when they multiply twice, they will give you 4? So indices now said, okay, let's just say it is 1 over 2. Because if we were putting the 2 here, what this will mean is 4 times 4 twice. But now we are no longer putting it that way. We are putting it like this to show that we are not doing 4 times 4 twice. We are actually looking for a number that will multiply itself twice that will give you 4. Imagine I had written 27 raised to the power 1 over 3. According to the suggestion given, we are saying that what we are looking for is actually a number that will multiply itself 3 times to give you 27. So this is where this law came into place. But rather than doing it like this, indices now said anytime we see something like this, let us use a symbol for it. And that symbol is actually the root symbol. So if it is 2 that is here, you will have square root. This is read as square root. But if it is 3 that is at the denominator, you put the 3 here to show that we are looking for the cube root, which means that we are looking for a number that will multiply itself 3 times to give 27. So let's say you have 16 raised to the power 1 over 4. This means the fourth root of 16. Now indices is saying which number are we going to multiply 4 times that will give us 16. That number is 2. 2 times 2 is 4. Times another 2 is 8. Times another 2, that's 16. So that gave rise to the sixth law of indices. So this is the mth root of x. So anytime you see this, it's the same as this. Although there are some other things, if you check your textbook, especially those doing engineering, when you check K-strand, you will see some things about this. So let's move to the last law of indices, and that will be all for this video. In our next video, we'll be solving questions extensively on indices, and we'll be done with it. It's quite an easy topic. Now, the seventh law of indices is actually a combination of this law and this law. That's the seventh law. It's a combination of the sixth law and the fifth law. So let's quickly do that. Let's say you have x raised to the power 1 over m. We said it is actually the mth root of x. The mth root of x. But let's say there's now a power here, another power here. Or let's raise it to, let me use this part of the board. If you have x raised to the power 1 over m, we said it is the same thing as mth root of x. Mth root of x. Now, what if I decide to raise it to another power n? So it means I will raise this side to another power m. You know, one of the rules of mathematics is that what you do to one side, you have to do it to the other side. Now, according to this law of indices, whenever you have a power already and you have another power, what do? You multiply the two power together. So I'm going to have x raised to the power n 1 over m times n. So this is the mth root of x raised to the power n. So 1 times n is n. So we have x raised to the power n over m. Now in indices, if I decide to find the mth root of x first before raising it to this power n, or I decide to raise it to this power n first before finding the mth root, it's the same thing I'm going to get. So this will now give us the audacity and the effrontery to write this here. So we have mth root of x raised to the power n. So this led to the seventh law of indices, where you have that if you have x raised to the power n over m, it is equivalent to the mth root of x raised to the power n. So that will be all for this video. In our next video, we'll be solving questions on indices, questions that leads you to simultaneous equation, question that leads you to polynomials if necessary, question that will lead you to quadratic equations, as the case may be. So thanks for watching. Please do not forget to like, subscribe to our YouTube channel, and share this video. Your success is our concern. Thanks for watching.